Welcome back to another project, and thank you so much for joining me once again as we continue learning new and exciting things step by step together. In this project, we are going to build a simple yet very practical to-do list application using JavaScript, where we can add, check, and delete our daily tasks easily. When you take a look at the final version of this project, you'll notice that we have an input field right at the top where we can type in any task we want to add to our list. For example, we can type something simple like buy milk or any other task we want to remember for later. As soon as we press the Enter key, the task is added instantly at the bottom of the list, appearing smoothly without needing any page refresh. You'll notice that the page stays exactly the same when the new task appears, which makes our application feel fast, modern, and user-friendly. Even if we refresh the page completely, all the tasks still remain on the screen because we are saving them permanently inside the browser's local storage. In this project, we're going to learn step by step how to set items, get them back, and manage them inside local storage using JavaScript so our data always stays safe. You'll also see two small icons beside each task. One is a check icon, and the other is a trash icon that lets us control each item individually. When we click on the check icon, that task will be marked as completed or done, letting us visually see our progress. And when we click on the trash icon, the selected task will be instantly removed from the list, keeping everything clean and organized. Even after refreshing the page, you'll see that the checked items remain saved, and the deleted ones are gone completely from the local storage of the browser. In the next section, we'll begin by creating the HTML structure for our to-do list, which will serve as the foundation for everything else we build. So, I'll see you in the next section, where we'll start writing the code step by step and bring our to-do list to life. Alright everyone, let's get our project started. Let's begin by opening Visual Studio Code, closing the Get Started tab, and selecting Open Folder from the File menu. I am going to create this project on my desktop, but you are welcome to choose any location on your computer. Let's click on the desktop, then select New Folder, and name this new folder To-Do List. With that, we press Enter and click the New Folder button. Let's close the Get Started tab once more, and then in the Explorer section on the left, we will create an HTML file. To create our new file, we simply right-click and select the New File option. Let's name this file index.html and press Enter. You will see our new HTML file is empty, but we can quickly generate a complete template by typing an exclamation mark. We simply type an exclamation mark and then select the first auto-suggestion that appears. Now we have our HTML5 boilerplate, and the very first line is the document type declaration that tells the browser which version of HTML we are using. Since we are working with HTML5, we simply type the word HTML here. Next, we have the HTML tag that wraps all of our page's content, including the head and body sections, and the language attribute within it defines the page's primary language. For this project, we will set the language to English. Moving into the head section, we find three meta tags and the title. The charset attribute specifies the character encoding, and for HTML5, we use UTF-8 as it includes nearly all characters and symbols. Next, we have a meta tag specifically for Internet Explorer, instructing it to use its most modern rendering engine, called Edge. Next, we have the viewport meta tag, which controls how the browser scales the page. This first part sets the page width to match the device's screen. For example, a mobile screen is naturally smaller than a computer screen, and the second part of this setting controls the initial zoom level. To help us see the complete code, we can turn on word wrap using Alt-Z. Setting the initial scale to 1 means the page loads at 100% zoom. The title tag defines what appears in the Browser tab. Let's take a look at our browser preview now. To see our page in the browser directly inside Visual Studio Code, we can right-click and select the Live Preview extension we installed earlier. Let's click here to see the browser preview on the right side, which currently shows an empty page with the default title, Documents. Next, we will change the title to To-Do List to match our project name, and then move to the body section where the main content visible in the browser will be placed. Next, we will add a form element for our to-do list and assign it a class of form. Since we don't need an action for this form, we can delete that part and add an input field with the class of input. We will set the input type to text. You can see our input field now, and we will add a placeholder text inside it that says, "Enter your task." That placeholder text looks perfect. We also want to disable the autocomplete feature. Let's set the autocomplete attribute to off. The autocomplete attribute simply disables those automatic suggestions for our text input. Next, we will add an unordered list tag and assign it the class of list for our task items. For our first list item, we will add an example task like buy milks and include 2 icons. We will add 2 icons for each list item, one to check items off and another to delete them entirely. To add icons to our project, we can use the Font Awesome website. Let's open up our Google Chrome browser and search for Font Awesome. We click on the first result, which is fontawesome.com, and then we select the icons section. We can browse through the many available icons and search for a checkmark. We click on the check square icon and copy the provided HTML tag, which is an I tag with the classes FAS and FA check square. The icon has been copied to our clipboard. Let's make this panel a bit smaller so it's easier to see. Right now we can't see the icon because we need to link to the Font Awesome library in our HTML code. Let's head back to the browser and open a new tab where we will search for cdnjs. The first result that comes up is cdnjs.com. We then click on this link and search for Font Awesome in the search bar, clicking the top suggestion. Now we need to scroll down a little until we find the link tag we can copy. Let's head back to Visual Studio Code and paste that link tag just below the title, right before the head section closes. Perfect. Now the checkmark icon appears in our browser preview. Next, we will add the trash icon for deleting items. Let's navigate back to the browser and reopen the Font Awesome tab we had earlier. Now let's search for a trash icon using the search bar. Let's click on the first result here. Just be sure to avoid the other icons that require a paid license. The free ones are solid black and not faded. We select the first free trash icon and copy its HTML tag containing the FAS and FA trash classes. We return to Visual Studio Code and paste the copied trash icon right after the checkmark icon. You can see the 2 icons are now sitting side by side. Let's copy this list item and change the text from buy milks to call David as an example. Now we have 2 items in our list, and we will add a checked class to the first one so we can style it later with a different color and a line through the text. In the next video, we will begin styling our project with CSS. That wraps up our HTML setup for now. In the previous section, we completed the HTML portion of our project. Now we are ready to bring our project to life with CSS styling. The very first thing we need to do is create our CSS file. To open the File Explorer, we can press Ctrl-Shift-E. Now, in the left-hand Explorer panel, we can right-click and select the New File option. We will name this new file style.css and then press Enter. To apply our styles, we must first connect our CSS file to the HTML document. Next, we will switch over to our index.html file and add a link tag right after the Font Awesome link, positioning it at the very end of the head section. We type the word link and then select the third auto-suggestion for the style sheet. This link allows us to use CSS in our project. We can close the Explorer panel by dragging this divider to the left. Now let's move over to our style.css file and begin styling our project. Let's begin by styling the body element first. Let's start by typing body and then opening our curly braces. Our first step is to remove the default margin. We are setting the display to flex so we can center the items horizontally. Let me just expand my browser window a bit more. To center everything horizontally across the page, we'll use the justify content property with a value of center. Let's go ahead and change the background color to something like green, or perhaps this color right here. Next, let's begin styling the form itself. Now that we have finished styling the body, let's move on to the form. Remember that our form also has a class of form. We will target the form class using the .form selector, and then we position it absolute with a top value of 30%. The reason we avoided using a full viewport height with centered alignment is that our list needs to be able to grow and scroll without being confined to a fixed screen height. By setting the position to absolute, we position the form relative to the body, moving it down by 30%. Let's go ahead and add a box shadow to give our form a nice shadow effect. For the horizontal shadow position, we'll set it to 0, then set the vertical shadow to 4 pixels, and finally set the blur radius to 8 pixels, which you can see taking effect here. We can clearly see the shadow effect now, but it is a bit too dark for our liking. To make the shadow less intense, we can use the RGBA color function to add some transparency to the black. Next, we write RGBA with parentheses and set all color values to 0, then use 0.3 for the alpha channel to create a 30% transparent black. I'll quickly press Alt+Z to enable word wrap so we can see all of our code clearly. Next, we will set the form's width to 400 pixels and experiment with the background color. Let's go with light pink instead, that looks much better. Let's round the corners of our form by adding a border radius of 10 pixels. That wraps up all the styling for our form section. Now let's move on to style our input field. Now, we need to style the input field, which has the class of input. First, we'll set the input's width to 100%, but you can immediately see it's actually overflowing. The reason we're seeing this overflow is that the browser is including the border width in the total element size calculation. So the solution is to set the box sizing property to border box. Setting the box sizing to border box is precisely the solution we need. As soon as we set the box sizing to border box, you can see the input now perfectly matches its parent's width. Next, we will add a padding of 20 pixels and round off the top corners of the input field. Let's apply a border radius of 10 pixels to the top left and top right corners, while keeping the bottom left and bottom right corners at 0. Now let's also remove that dark border around the input field by setting the border property to none. Now that looks much better, so let's change the font size to 20 pixels for better readability. This change gives us a much cleaner and more attractive font style. You might notice the placeholder text is a bit too bright. To change the placeholder text color, we will target the pseudo element. To style the placeholder text, we target the input class and use the placeholder pseudo element to set the color to a light gray. That covers everything we need for styling the input field. Let's move on to style our unordered list section. The unordered list element has a class named list. Next, we will style the unordered list with the class of list by removing its default padding and margin. This gives us a much more compact list without the gaps. Next, we need to get rid of these bullet points. The reason we have these dots is that list items have bullet points by default. Those bullet points you're seeing come from the list items themselves. Now, inside the list, we target the list items and set the list style type to none to remove those dots. Then we add some padding of 20 pixels, change the font family to cursive to match its parent. Next, let's add a dotted border to the top of each item to create some visual separation between them. Now we need to update the color for both the text and the border. That should make the border color much more distinct now. Now let's move on to styling these buttons. We'll position the check and trash icons on the right side. To style the buttons, we need to target the trash and check classes. Now, to style the trash icon, we need to target it specifically by using its class. Let's begin by styling the trash icon and setting its color to red. You can see right away that the trash icon is now red. We set the position to absolute so we can move the trash icon to the right side. Now we need to set the parent element's position to relative because we want these icons to be positioned absolute relative to their direct container. We set the right position to 10 pixels to move it over, and setting top to 50% would normally align the top edge of the icon to the middle of its parent. To center it perfectly, we use the transform property with translate y set to -50%. Next, we change the cursor to a pointer so users get a visual cue that these are clickable buttons, and we apply the same styling to the check button, but set its color to green and position it 20 pixels from the right edge. For the check button, we can copy this same code block using the keyboard shortcut and then change the class name to match our check icon. The main difference here is that we set this color to green and position it at 20 pixels instead of 10 so it doesn't overlap with the trash icon. Let's try increasing that to 40 pixels for the right position. That positioning looks good for our buttons. Now let's change the form's background color from pink to yellow. I think the yellow background looks much better. Let's go ahead and change the form's background color from light pink to yellow. The yellow background makes the red and green buttons really stand out nicely. Feel free to choose any color that fits your personal style. Next, we want to style our list items that have the checked class. For the items we've checked off, let's make the text appear lighter with a line through it, and we'll also change the check button to a gray color. To target the checked list items, we first select the list, and then find the list items with the checked class, where we change the text color to a light gray and apply a line through decoration. We will add a text decoration of line through to create a strike-through effect through the middle of the text. Let's try changing that to a darker gray instead. That is a much better visual balance for our list items. We should also update the color for the check button. Next, we target the list items with a checked class, and then specifically target the check icon to change its color to dark gray. That's looking much better now. So now, if we add this checked class to any list item, you can see we get this exact effect. Let me demonstrate this by cutting the checked class from this list item and pasting it onto the next one, which immediately applies the strike-through effect. In the next section, we will implement this exact behavior dynamically using JavaScript when the button is clicked. So clicking this button toggles the effect on and off. When we click the trash icon, we want to delete the entire note. Now that our styling is complete, we will bring our project to life by adding functionality with JavaScript. That concludes our CSS styling, and I will see you in the next section. In the previous section, we completed styling our project with CSS. Now we're ready to bring our project to life by adding interactive features with JavaScript. The very first step is to create a new JavaScript file. To open the File Explorer panel, we'll use the keyboard shortcut Ctrl-Shift-E. Now, in the left sidebar of the Explorer, we can right-click and select New File. Let's give our new file the name index.js. We drag this new JavaScript file into our workspace right after the CSS file. Before we can use our JavaScript file, we need to link it inside our HTML. Now we return to our index.html file and scroll down to the very end of the body section, where we will add a new script tag by simply typing scs and then selecting the second auto-suggestion, which conveniently includes the source attribute we need. Now we have our script tag, and the src attribute defines where the file is located. Since both our HTML and JavaScript files are in the same folder, for the source URL, we simply need to type index.js. Perfect. Our JavaScript file is now properly linked and ready to use. With our JavaScript file successfully linked, we can now begin implementing functionality. After saving the HTML file, let's switch over to our index.js file. Now we need to access the form element from our HTML using JavaScript. As we discussed earlier, the form element uses a class called form. We can retrieve that form element using the query selector method. We'll create a constant and use document query selector to target the form element by its class. To select an element by its class using the query selector method, we must begin the class name with a dot. We can press Alt+Z to activate word wrap for better code visibility. Since we no longer need the Explorer panel open, let's go ahead and close that as well. Now we are going to add an event listener method to the form. This is where we can capture whatever the user types into the form by using the submit event within our event listener. Now we will attach an event listener to our form element. The add event listener method requires two parameters to function correctly. The first parameter specifies the event we want to listen for, and the second parameter is the function that will execute when that event occurs. The event type we will be listening for is called submit. When the form is submitted, we will trigger a function. Now we need to trigger our to-do list function, which will add whatever is written in the input field to a new list item. Let's open the browser now to see what happens when we submit the form. To see how the form currently behaves, try typing some text into the input field and pressing the Enter key. If you look closely at the icon here, you will notice the page refreshes when we submit, but we actually want to prevent that refresh so the new item gets added without reloading the page. Now let's return to Visual Studio Code where we can access the event and prevent its default behavior. To prevent the page from refreshing, we will add the prevent default method. To prevent the page from refreshing, we call event.preventDefault with parentheses. This method effectively stops the page from refreshing. Let's test this in the browser by typing a task and pressing Enter. You'll notice the page no longer refreshes. Now let's head back to our Visual Studio Code editor. Next, we'll call the function we just created, which we'll name to-do list. Let's make sure we use camel case for this function name as we created here. Now, we will define the to-do list function to gather information from our form. Next, we need to capture whatever value the user types into the input field. To capture that input value, we need to first select the input element within our JavaScript code. Since our input field has a class name of inputs, we can use the same query selector method we just used to retrieve that element. Next, we create a constant called inputElement using document query selector with .input inside the parentheses. To see this in action, we can open the browser's developer console by clicking the hamburger menu and selecting Open DevTools, then navigate to the Console tab. If we try typing something in the input field right now, nothing appears in the console. Now, if we place this console log inside the form submission event handler, for example right here, and then we type something and press Enter, which submits the form, we can see the result. We can see the text we typed into the input field right here in the console. For example, if we type hello and press Enter, we can see hello appear in the console. That means we can retrieve whatever text was typed into the input field by using inputElement.value. Now we will remove that console log statement and work within the function that gets executed here. Now let's create a new function for this task. Next, we will create a variable to hold the new task. We assign the value from our input field to the new task variable. Now that we have captured the input value in our new task variable, we need to create a new list item element to display it. We have been hard coding our list items so far, but we can create them dynamically with JavaScript. We will now create a constant called li_element using the document.createElement method. Now we want to set the text inside that list item, so the li_element.innerText would be the new task. To display this list item in our interface, we must append it as a child element to the unordered list. Now we need to access this unordered list from our JavaScript code. This unordered list element has a class called list. We will retrieve that element in the same way we did before using the query selector method. Now we need to grab that unordered list element by its class name list using the document.querySelector method. Now we will append this newly created list item to our unordered list. Next, we use the appendChild method to add this list item element into our unordered list. Let's test this out by typing something into the input field and pressing Enter. You'll see a new list item appear with the exact text we just entered. First, we take the value from the input field and store it in our variable. Then we set the inner text of the list item element to that value and append it to the list. That's working perfectly for adding new tasks. Now let's make sure we clear out the input field after submitting. Once we submit the form, we should clear the input field. Next, we will set the input field value to be empty after submitting. For instance, When we type hello and press enter, we see the new task appear in the list while the input field is cleared because we reset its value to be empty. Now we need to create the check and trash buttons inside each list item. We can create these buttons using the same createElement method. We are going to place each of these icons inside its own separate div element. This will allow us to add click event listeners to these buttons later. Next, we will create a constant for the check button element. We will create this element using the document.createElement method, making it a simple div container to hold our check icon. We can set the inner HTML property of our check button element by using backticks and pasting the icon code we copied earlier. Let's copy the icon code for the check button. Let's copy this icon tag and paste it into our JavaScript code. To make this icon appear inside our list item, we need to append it as a child element. Now, we'll append the check button element as a child to the link element we created earlier. Let's test this by adding a new task like hello, and we should see both the text and the check button appear. Now let's create the trash button using the same approach we just used for the check button. Next, we create the trash button element using document.createElement, and we specify div as the element type because we want it to be a div container. Let's do the same for the trash button by copying the second icon section and pasting it here. Let's test this by adding a new task like hello again. I notice we haven't appended the trash button as a child element yet, so we need to add that line to connect it properly. Let's test it again by typing hello and pressing enter, and now we can see both our text and the icons appearing correctly. Now, let's remove the two hard-coded list items we created earlier so we can focus solely on the items generated by our JavaScript code. Let's return to our JavaScript file now. Next, we need to add an event listener to the check button. When we click on the check icon, we will add the checked class to apply the strike-through and change the item's color. We have already styled these elements with CSS, and now we simply need to add the checked class. Next, we'll add an event listener to the check button element. For the click event, we want to trigger a function that adds the checked class to the list item. We will now target the list item element's class list property. We use the toggle method so a single click adds the checked class and another click removes it. Let's test this by typing hello again, and we can see it appears here. When we click on this checkmark icon, the checked class gets added to the list item. This action toggles the class and updates the styling. When we click the check icon again, the styling returns to normal since we removed that class. Let's test this functionality directly in the browser. We can observe the classes being added and removed in real time. Now let's head over to the browser and add a task. Then open the developer tools by pressing Ctrl-Shift-C. Looking at the form section in our list now, you can see the new item we just added. We can see the text says hello and there are two div elements. Let's open up this first div to see that it contains the check icon. When we click on the check icon, the class checked is added to the list item. And if we click on that same button again, we remove the checked class from the list item. Perfect! That functionality is working exactly as expected. Let's return to our code editor in Visual Studio Code. Now let's add functionality so that when we click on the trash icon, we completely remove this task from our list. Next, we add an event listener to the trash button element for a click event, and within that, we simply call the function to remove the list item element. We simply call the remove method on the list item. Let's test this out in the browser to see if it works. Let's test this by adding a couple of tasks, and you'll see that clicking the check button still works. And also clicking the trash icon will successfully remove any task. That's working exactly as we intended. As you can see, we have a problem where any task we add will disappear if we refresh the page, because we haven't stored that information anywhere. The issue is that our data is not being saved. The important thing to note is that we aren't using a traditional database. For this project, I want to use the browser's local storage to save our data. For this project, we will use the browser's local storage to save our information. You can find the local storage in your browser's Developer Tools under the Application tab, where you'll see our website's URL listed. As you can see, the local storage is currently empty, and our goal is to save our to-do items there. To store our tasks, we will create a function called update local storage. Now we are going to create a new function that will check all the list item elements. First, we create a constant for all the list items by using document query selector all to select every li element and store them in a variable. We will start by creating a variable named lists as an empty array and then loop through each list item with the for each method. This means we will trigger the function once for every single element in our list. We loop through each list item using for each, and for every single task, we create an object that gets added to our main list array. The first property we'll store is the task's name. We also need to save if the item is checked or not. To check whether the task is marked as completed, we test if the list item contains the checked class, which will give us a true or false value. This check property will be true if the element has the checked class and false if it does not. Once we have this variable ready, we can save it to the local storage. Next, we will store this data using the local storage set item method. First, we need to set the name of the variable we want to store in local storage, which we will call list. Since local storage can only save strings, we must convert our array into a string using the JSON stringify method, and we simply pass in our list variable. Next, we need to call this function from within our to-do list function. Next, we need to call the update local storage function. Let's test this by typing hello and seeing that a new key called list appears in the storage section. As you can see, this entry has two parameters. You can see the first item has the name hello and the checked status is set to false. However, if we check an item, the local storage doesn't update because we haven't called the update function within our event listener. We should also update the local storage whenever we check an item or remove a task. Let's add a few sample tasks and observe them appearing in our list. Now if we mark the first task as completed, you can see its checked status changes to true in the storage. Notice how the check status has now changed from false to true. Let's go ahead and click the trash icon to remove it. As you can see, when we remove an item, it also disappears from our storage. We have now successfully stored our task data in local storage. However, you might notice that when we refresh the page, our tasks disappear because we haven't yet used the stored data to rebuild the list. The problem is that we stored the data but never retrieved it. Now we need to initialize our list variable at the very top, before the form event listener, so we can call it and retrieve the data from local storage. Next, we need to retrieve our stored data by accessing the local storage. Now we need to use the local storage method again, but this time we'll use getItem to retrieve the data instead of setItem, which we use to create the storage item. To retrieve our stored data, we should use the getItem method. The specific key we want to retrieve from storage is called list. The problem is that this method returns a string, which we cannot directly use to build our list. To use this data effectively, we need to convert it from a string back into an array. To convert this string back into an array, we use the JSON parse method. What we need to do now is cut this line and place it inside the parentheses here. Now let's check our progress by using console log to display the list, and if we look in the console section, we can see that we are successfully retrieving the array that exists in our local storage, which confirms it's properly stored as an array rather than a string. For example, if we remove the JSON parse method right here, you can see we get back a string instead of an array. By using JSON parse, we successfully convert that string back into a usable array. Now that our list variable holds the complete array of tasks, we need to loop through each one using the for each method. Now for each task in our stored data, we want to pass it into our to-do list function. To make this work, we need to call the to-do list function for each task and pass the task data into it. Now you can see we are retrieving both tasks from storage, but the actual content is missing because we haven't implemented the code to extract the task name and checked status yet. After retrieving the task from storage, we assign the task's name to our new task variable. Let's head back over to the Application tab again. As we can observe in the console, the name appears as undefined. Let us delete these existing tasks and create a fresh one. You can see the result displayed in your browser right now. Now, if we refresh the page, you can see that our Hello task remains in place because we are retrieving it from the local storage. Let's add a few more items to our list. Even when we delete these items and refresh the page, we can see that the same information is still there. However, if we check an item and refresh the page, you'll notice it becomes unchecked because we haven't yet incorporated the check status into our storage logic. Now we need to add an additional condition to check if the task is marked as completed. To complete this condition, we need to add the double ampersand symbol. This condition ensures that both values are set to true. Now we need to perform this step after we've created the list item because we need to reference that specific element. After creating the list item, we need to add the checked class to it if the task was previously marked as complete. Perfect. Now let's add the class for checked items. This demonstrates that our checked state is now persisting through page refreshes, and we can also delete items and add new ones like buy something to see the complete functionality working together. As you can see, our application is now fully functional. We can check items off the list, see the visual changes, delete tasks directly, and add new ones. That wraps up our interactive to-do list project. I hope you found this project enjoyable and educational. This was a substantial project, but learning to build a to-do list is incredibly valuable for any student as it covers so many fundamental concepts. I genuinely hope you had fun and learned a lot from building this project. Thank you for following along, and I will see you in our next project.